Okay, today we take a look at what happens when we divide exponential expressions, and we're going to give birth to this thing called the quotient rule of exponents. So let's consider this expression here. So we have 2 to the 5th, and it's getting divided by another exponential expression, 2 to the 3rd. So here, we can expand the numerator. 2 to the 5th just means that we're multiplying 2 by itself 5 times. And then for the denominator here, 2 to the 3rd just means that we're multiplying 2 by itself 3 times. And now here in algebra, something that hopefully we've learned by now is that we can cancel out common terms. So here we can cancel these 2's, we can cancel these 2's, and we can cancel these 2's. So there's nothing left in the denominator. And in the numerator we have 2 times 2, which if we write in exponential form, that's just 2 to the 2nd power. So we get that 2 to the 5th over 2 to the 3rd is the same thing as 2 to the 2nd power. And hopefully after looking at this for a couple of seconds, you realize that the pattern here is basically the exponents getting subtracted. So here 5 minus 3 gives us this exponent of 2. And that's exactly what the quotient rule tells us. So let's take a look at the definition. So suppose m and n, these ones are exponents, and suppose x represents a base. If you have the same base and you're dividing two expressions, again with the same base, you can subtract their exponents. So let's take a look at some examples. Let's begin with this one. So here we have the common base of 7, and then the exponents are 12 and 3. So by using the quotient rule, we can grab the same base, or the common base of 7, and then subtract the exponents, 12 minus 3. That's going to give us a grand total of 7 to the 9th power. And we leave it as 7 to the 9th because the question is asking for exponential form. Now, this also works for variables. So here we have x to the 10th over x to the 7th. So the common base is x. So we can get x, raise it to the 10 minus 7. So the numerator subtracted by the power of the denominator. And here we get x to the 3rd power. Alright, let's take a look at a couple of more. So here, the quotient rule also works when you have more than one base. So I'm going to rewrite this expression as, I'm going to keep the numerator as is, but the denominator, since I have a product here, I can just move them around. So I'm going to have 2 to the 1st power times x to the 2nd power. And now I can apply the quotient rule to the 2's, and I can apply the quotient rule to the x's here. So let's begin with the 2's. So here I get 2 raised to the 3 minus 1 multiplied by x to the 5 minus 2 to get a total of 2 to the 2nd power times x to the 3rd power. Alright, let's try this one more time. So here I don't need to move them around because the common terms are already aligned. So here x has a power of 1, y has a power of 1. So we get x to the 2nd minus 1 multiplied by y to the 3rd minus 1 to get a total of x to the 1st power times y to the 2nd power. And we can clean this up a little bit and write it as x y to the 2nd. Alright, time for some practice.